Ben Hurd is the Executive Director of Bright New World, a fantastic NGO based out of Adelaide. And we will also be hearing from him tomorrow, but here he is.
Thanks, Stuart. Thanks very much, and thank you so much for the invitation. I really am pleased to get an invitation to come to an event like this. I think it's incredibly important. Tomorrow I'll be giving a much broader point of view of how I see nuclear technology as fitting into a broader worldview about what's important and what we're trying to achieve. But today I'm just going to build a little bit on Mark's really good introduction. We've known each other for ages, but I think it's the first time we're double teaming presentations. That was a really good introduction, so I'm just going to offer a little bit more. In a presentation I've called it How Much, How Clean, How Cool. So I want to talk a little bit about some of the economic and commercial issues relating to nuclear power, particularly for Australia. How clean, just give you some of the data about the greenhouse gas emissions for nuclear power, and how cool, just talk about a couple of the other nuclear innovations as well. I think the first one, how much, is probably very important for this gathering because I think nuclear technology, nuclear power, is one of those issues where you're going to find many, many characteristics that you feel right at home with supporting. For a range of reasons, and I'm not an expert in libertarianism or libertarian thought, but that feel quite at home. And then some of the commercial and economic realities you may find you need to make some sort of a trade-off at the moment. It all depends a little bit, but let me explain what I'm talking about. Okay, so how much does nuclear power cost? It seriously depends where you look, and so I'm really, really glad that Mark pointed out the build in the UAE as an example. You have to go global with the data. Australia has a predisposition to look to the USA and the Anglosphere or Western Europe and say, we're like them. It's kind of this weird racial prejudice, like they're white and speak English, so we'll do the same nuclear as them. No, the Opal reactor was built by the Argentinians. We had an open global tender. Okay, because we don't have a sovereign interest in nuclear. We don't have a Westinghouse that will definitely build it or a Rosatom that will definitely build it. We would have something competitive. If you are competitive and if you have get into a mode of being well practiced at building nuclear power, you can start to make it quite cost effective. Does that have a zapper? It doesn't, that's fine, I've highlighted it. You can see the enormous discrepancy between, for example, the United States and Korea in the cost per megawatt hour of electricity for nuclear power. It's huge, so that prejudice can be very expensive. If we have an open global tender and we ask providers to sharpen their pencils, nuclear power is available at a good price. Now, top line here, the investment cost. This is really critical, and this is one of those commercial issues that you are going to need to consider. Because particularly at the moment, before the advent of factory-built SMR, we are talking about a lot of capital expenditure at the front of the process. If you want the benefits of nuclear power that it offers, and particularly the longevity that Mark spoke about, if you're applying a discount rate of much above 7%, your cost-benefit analysis can't see any benefits beyond about 20 years. Okay, so long-lived projects that offer intergenerational social benefits are much better, the benefits are much better represented with a low discounting of the future. It's basically saying if this is still providing power in years 30, 40, 50 and 60, we still want to see that benefit. So what I'm talking about here is if you've got a large CapEx project with a long life, it needs cheap money. Okay, and at the moment, cheap money mainly comes out of government agreement and guarantee. So private capital markets will not want to particularly drop $25 billion for something that has a 4 to 6 year build and a 60-year design life. Okay, so if we're wanting private capital markets and insisting on discount rates of 7% and above, 10 or 11%, we will build solar panel PV farms that can be up and running within 9 months, wind farms and gas. Okay, so that's what private capital markets will reward currently in energy. All of these benefits of nuclear power are very hard to get unless we're prepared to have cheap money. And that's about acknowledging things like climate change is important. We need to manage that risk. So clean energy for 60 years has value. Clean air for 60 years has value. Okay, so if you want good cheap nuclear, we can have it, but it requires good cheap money, basically. There would be many other bits of infrastructure that could be thought of in a similar way. Roads, bridges, airports, all sorts of things like that. Lower the capex, a high capex, you need cheap money. So there's a couple of decisions to make there. And again, these projected price discrepancies still really, really high. Now, in this case, a 5% discount rate. Pretty appropriate. If you can get 5% money, you can do really well. So some of the international nuclear developments at the moment, they're tied to really good financing programs from Russia or China. So to make the capital expenditure available at a good rate. So that's a little bit about how much. How fast, how clean? How does nuclear power actually rate as a climate change response? It seemed axiomatic that if you're interested in climate change, you'd have to be very interested in nuclear power because it's low carbon, reliable energy. And yet you don't see that in so many people that ostensibly look like me, but are hardcore anti-nuclear. And they'll often say, it's too slow to get the job done, and it's not even clean anyway. So just to quickly look at that, it's as fast or as slow as you want it to be perfectly honest. If you want to regulate something out of existence, you can. Okay? If you want to safely regulate something into existence, you can. As it happens, corrected for population, which is the graph in the top right, the fastest additions of new energy over a period of time per head of population have been committed nuclear build programs. Yes, a reactor takes some time to come online. When it comes online, it brings a huge amount of power with it. The UAE, which is one of the lines here, that dashed line at the bottom, that's that current program that Mark has talked about. They're building 4 reactors in series. And when people say it'll take Australia 10 years to build a reactor, well, yes, it would also take Australia 10 years to build 5 reactors. That's very important. It's like hanging out the laundry. You don't hang out your underpants and wait for them to dry and then hang out your socks, right? You hang out all the laundry, okay? Same thing with nuclear build. You can build a bunch of them. And the best ever case worldwide was Sweden. From between 1966 and 1986, they put on a huge amount of clean electricity using nuclear power. If we want to do it, we can do it, okay? How clean? Very clean. So life cycle greenhouse gas emissions of a range of technologies here. The source is the National Renewable Energy Laboratory of the United States, so there can't really be any accusation of a pro-nuclear bias here. For nuclear, we're talking in the range is very high, but the mean is very low, so there are some real outlying studies up here. Extremely clean, very, very similar to wind, and generally speaking, a little cleaner than solar PV and solar thermal. But for me, as an environmentalist, low carbon guy, that's all much the same. Saying nuclear is even cleaner than solar is a little irrelevant. We're talking about the difference between pretty small numbers compared to things like brown coal and black coal. So is it a climate change response in that regard? Yes, it is. Okay, so how could we use it in Australia? This is some of the modelling I've done for the end of my thesis, looking at the Australian national electricity market. We took hourly demand in 2030 for Australia, and we did a couple of different models. In this one, we've combined just nuclear and gas. So we've taken all of the projected rooftop solar and Australia's existing hydroelectric facility, and we've taken them off the demand. That's left us with a residual hourly demand. We have to meet that residual hourly demand. In this model, we try to meet it just with nuclear and gas. So that would take 26 gigs of nuclear, a little bit of gas. Average levelised cost $97 per megawatt hour. That's a lot more expensive than the NEM average today. That's something we're all going to have to get used to. So long since built and depreciated coal assets will close. We aren't going to have power at $30 a megawatt hour from big new assets to be built today. But in a couple of decades' time, the new price starts to look okay. Something that's incredibly important in competitiveness in Australia isn't just how much the price is, but is it steady and reliable? Is it predictable, and does it offer certainty for investment? Fortunately, this does. But we'll see how it compares. So what we can see here is the proportion of nuclear supply. If we just run nuclear and gas, it gets cheapest with nuclear doing about 95% of the supply, and gas can ramp up and down to get the rest of the supply. And we get a very, very clean grid. So in theory, it could be done. Another Oh, I thought I was going to show you another one. We also modelled nuclear, wind, solar and gas all together. And we find they can also actually work really, really well together, provided we're not using too much wind and solar. They're quite larger, much larger wind and solar sectors, yes, but not trying to get them to do absolutely everything. But obviously, I decided you wouldn't be interested in that. How cool. There's a little bit more advanced nuclear that's worth looking at. It is a reasonable point that Australia is going to have a lead time between now and whatever our first nuclear reactor is. It is actually completely plausible that our first nuclear in Australia might be a small modular reactor, might be one of these more advanced small modular reactors. That's quite plausible. And it's also an extremely attractive discussion point for most Australians, quite interested in small modular reactors and these more advanced reactors. And also in terms of capital markets, it's easier. So a couple of other things that are available. Terrestrial Energy is a Canadian company. They're devising a molten salt reactor. So where Mark has talked about solid fuel rods in a reservoir of water so they can't melt down, in this case the fuel is melted already. So it's a liquid fluoride salt that has the uranium dissolved in it. They make little reactor cans that are actually designed to swap in and out with 7-year lives. So it runs for 7 years and they swap it out, keep it in there, put in a new can, and the balance of the plant remains the same. Quite an innovative design with the intention of lowering cost. This is what terrestrial has all been about, cheaper, cheaper, cheaper. Something very important is the outlet temperature, 600 degrees Celsius. That's also quite different from today's pressurised water reactors, much higher temperature. So they describe this as a heat plant. If you want to make electricity, you can, but you might want to make heat because you might want to make hydrogen. And from hydrogen, you might want to make ammonia and fertiliser. We use a lot of heat in industry in Australia, and it's all gas and coal. And you can't make 600 to 1,000 degree heat with wind turbines and solar panels. No one's arguing about that. There's dispute about the electricity market. There is not dispute about industrial heat. We don't have an answer unless we can make high temperature nuclear reactors, and with high temperature nuclear reactors, make clean synthetic fuels to burn. Okay? And it's about a third of our energy. Okay? Electricity transport industry, it's about a third. It's massive. So the high temperatures of these reactors is really, really important. They're doing really, really well. So terrestrial's making up good ground. Another one to look at is PRISM. This is where we can actually recycle the old nuclear fuel in a nuclear reactor to get new clean energy. So where Mark talked about slowing the neutrons down with the water, in this type of reactor, we keep them fast. Keeping them fast means that when they do connect, they can do something called breeding, which is make new fuel out of old material, which is quite helpful. Trade-off is you need slightly more enriched fuel so that you can actually get that process. But it works, it's designed really well. The design of this is actually incredibly mature. Unfortunately, General Electric Hitachi are struggling to come up with funds to actually put it through licensing. It's one of the chicken egg processes of nuclear. Unless you have a customer, the cost of licensing and regulation is unbelievably high. So they're sort of sitting on this design and trying to find a pathway through. Metal fuel, it cuts out when the reaction gets too hot, that's great. Cooled with metal, it removes heat passively all day long. You can kill all the power and it'll just remove heat all day long because the liquid metal removes heat faster. Really, really great design that I like. It's actually got decades of knowledge behind it, but again, commercially getting it to market has been the challenge. And finally, something I like to point this one out to say that innovation in nuclear, it's not always as exotic as that. This is just better fuel rods. It's really simple. Actually, it's probably not that simple. To be honest, it's probably not that simple. But they've come up with a better fuel rod design. Okay, so after 50 years, we've been using cylindrical pellets. Lightbridge is saying, let's use spiral helixes, and they get far better contact, they get far better heat transfer. These new fuel rods would require no change to the existing nuclear power plants, but they might get 10% more power. Like, given that nuclear power currently provides 10% of global electricity, just better fuel rods could add 1% of global electricity as clean power. It's amazing. So it's worth pointing out that nuclear is actually, it's only 50 years old. We're actually really only scratching the surface of the potential of nuclear technology. And Australia, with our clean slate, and our know-how, which Mark's even downplaying it, Australia is actually really highly regarded, we could indeed do very, very well if we chose to. I think that was it. Yeah. So just, oh, that's what I just said. That's easy. What I said. All right, thank you very much. That was helpful.
Thank you.